7.3b quotient rule. The quotient rule says that when there is a fraction underneath the radical, we can split it apart to give us square root a over square root b. This also applies if they're already separated, such as the case if I had the cubed root of 2 over the cubed root of 4. I could put these together as one large cube root of 2/4. So as you can see, you can go either way. It may be helpful to reduce the fraction first and then the radical second. Let's see this in example 1. Here's example 1. As you can see, both the numerator and denominator have matching radicals, so we can therefore put it all into one radical as 48 over 150. Now we're able to reduce this fraction. We know that 48 and 150 are both divisible by 2, giving us 24 and 75. We then know 24 and 75 are both divisible by 3, giving us 8 and 25. 8 and 25 are now no longer have common factors. So we can split them back into their own individual radicals, giving us the square root of 8 over the square root of 25. We know that the square root of 25 is 5, and that 8 is actually 2 to the third, so that gives us 2 radical 2. We have now simplified our problem. Let's look at example 2, where we've added some variables. Here's example 2. As you can see, there's things that can be reduced before we worry about the radical. So let's start there. We know that 5 goes into 20 4 times, and that 5 goes into 225 45 times. Next, let's reduce the x's. We have x to the 7th in the numerator and x to the 3rd in the denominator. That means there's 4 more in the numerator. So we cross off both and rewrite that there are 4 more in the numerator. Let's rewrite this so it's clearer. Now that we have reduced everything on the inside, we can now use the quotient rule to split these apart. Now that we have them split apart, we can now pull out anything from each of the radicals possible, or simplify the radicals. We know that 45 is really 3 squared times 5. So we can pull out a 3, and a 5 will stay in. X to the 4th comes out as x squared. In the denominator, the square root of 4 is 2. This gives us our final answer. Remember, when you are doing problems in which there is a radical and the fraction is inside of the radical, make sure to reduce the fraction first and the radical second.